Again, you're welcome to this class. Check out this exponential challenge here. The question is 2 to the power of 2 or raised to the power of 2. Then equal to 16 to the power of 2 or raised to the power of 3x. This is a simple one. If you know how to manipulate powers, okay? So we take our solution here. Here we are looking for the value of x here. Okay, so let's put the question down. 2 to the power of 2 further raised to the power of x equals to 16 to the power of 2 further raised to the power of 3x. Now, if you look at the base numbers here, we can express them in the same number. In other words, 2 being the smallest base number, then we can equally express our 16 in base 2 also. Right? So 16 is written as 2 to the power of 4. So if we do that, this is going to give us 2 to the power of 2 or raised to the power of x. This is equal to our 2 to the power of our 4 in bracket. This expression here, we have 2 to the power of 3x. Yeah. So with this here, look at this. We are having a power here. We're equally having a power here. So the law in indices says that if you have your a all raised to the power of your m there times n, this is equal to your a raised to the power of your m, or in bracket raised to the power of n, which is same thing as your a raised to the power of your n, or in turn raised to the power of m. Okay, this is simple law, right? Good. So, but however simple it is very important in solving exponential equation. All right. So with what we have here now, look at this. So we can use this to times this. So we're going to come up with our 2 to the power of 2 or raised to the power of x. This is equal to our 2 to the power of 4 times our 2 raised to the power of 3x. Good. So we're having the base here and this base here to be the same. Okay, and they are greater than 1. So what happened? It means that the powers can be equated. So if we equate the two powers, then we're going to have here 2 to the power of x. This is equal to our 4 times our 2 to the power of 3x. Good. Look at this 4 here now. Okay? This 4 can also be expressed in base 2 because we are having 2 here. And so let's continue on this side here. So this is going to give us our 2 to the power of x here, which is this very one, is equal to our 2 to the power of 2. This 4 here is what we just expressed as 2 to the power of 2 here now. Bring down our multiplication sign here times 2. Then we have here 2 to the power of 3x. Easy. Now we succumb to another law in indices, okay, which says that if you have your a, right, raised to the power of your m, okay, your m, then plus your n, so this is equal to your a to the power of your m times your a to the power of n. This is what it means. So what does it mean? Since the bases are the same, we can add the exponents here. So we're going to have here 2 to the power of x equal to our 2 to the power of 2, then plus our 3x. Easy. Now what we do again, you observe that the base numbers are the same here again. So you can equate the exponent. So this now in terms means x is equal to our 2 plus 3x. Subtract x from both sides of the equation. So this is going to give us our x minus x equals to 2 plus 3x minus our x. This leaves to give us 0. So we're going to have our 3x minus x plus our 2 equal to 0. This is a linear equation. So 3x minus x will give us 2x. So we have here 2x plus our 2 equal to our 0. Move this to this side, or we subtract 2 from both sides of the equation again. So we have 2x plus 2, then minus 2 equals to 0 minus 2. So this leaves. We are now left with x is equal to minus 2. So divide through by 2. And so it's going to give us x is equal to minus 1. So the value of our x from this exponential challenge is minus 1. But let's do a simple check if this actually satisfies the original equation. We want to plug in the value of x, which is minus 1, into the original equation. So let's take our check here. So we have here check. We have 2 to the power of 2 further raised to the power of x equal to our 16 to the power of 2 further raised to the power of 3x. So this is going to give us 2 to the power of 2 all raised to the power of minus 1. Right? Then this is equal to, we have our 16 to the power of 2 raised to the power of 3 into our minus 1. Okay, remember we said 16 can be written as 2 to the power of 4. And so this is going to give us 2 to the power of 2 further raised to minus 1. This is equal to our 2 to the power of 4, then in bracket, raised to our 2 raised to minus 3. Easy. Good. So if we use this to time this, then this is going to give us 2 to the power of 2 raised to minus 1 equal to our 2 to the power of 4 times 2 raised to the power of minus 3. Mind you, 4 can be written as 2 to the power of 2, right? So this is going to give us, let's continue here, this is going to give us our 2 to the power of 2 further raised to the power of 2 times 2 to the power of minus 3. So we apply our law here because the bases are the same, so we can add the exponent. So 2 minus 3 will give us what? Our minus 1. So here we're going to have here, let's start from here. So this side we have 2 to the power of 2 raised to minus 1 equal to, we're going to have here 2 raised to the power of 2. Here we say 2 minus 1, 2 minus 3 will give us our minus 1. So we have minus 1. Look at what I have here now. 2 to the power of 2 raised to minus 1 equal to 2 to the power of 2 raised to minus 1. So this shows that the answer we solve for x equal to minus 1 actually satisfies the original equation. Again, this is a simple one. Thank you for watching. See you in our next class. Bye.